So good morning to all. So do you have any doubts in your previous class from the previous class? From your ascending or descending order? To write a program to arrange a series of 32-bit numbers in ascending or descending order. So if you have any doubts, all of you gone through that one, right? Students, are you able to listen?
No doubt, sir.
Okay. So just I will brief it out. What are the different flags it is going to use, the different branch instructions which have been there. So this we have discussed in your second module itself in the beginning. So this is the part where you require most. So when you are writing the assembly language programming with respect to the ARM. So it is not with respect to the ARM. If any of the microcontroller or any of the microprocessor, if you have those microprocessor or microcontroller will be having their own instruction set. So and they'll be having its own flags. So depending upon the flags only, they are going to work. So when you're writing the code, you should have whenever the conditional statements are going to come. So you should be familiar with the flags status, how the flags is going to work and all. So just I will brief it out. This is already we have done in the class. So just I will brief it out for you. So one time. So the mnemonic EQ is for what? So we are going to have the flags. So the flags, how many flags you are going to have in your ARM instruction set?
Three.
Flags 3. Any other answer? What are they? 3 flags. So totally there are 4 flags. Okay. So 4 flags will be there in your ARM instruction set. So it is N, Z, C, V. So where the N stands for negative. Okay. Z stands for 0 flag. So C stands for carry flag. Okay. V stands for overflow flag. So totally there are four flags which will be there. So depending upon those 4 flags, you are going to make use of these particular flags when you are writing your code. Okay. So now whenever you are going to have the conditional statements when both are equal. So when they are both are equal, it is going to check for the condition flag 0. So where the capital letter Z stands for 1. That is your size 0 flag is set to 1. Okay, your 0 flag is set to 1. The capital letter indicates that it is 1. Small letter indicates it is 0. Okay. So and it is not equal means what? So your not equal means your Z flag is 0. The Z flag is 0. So depending upon the condition. Okay. So next is carry set. I assigned higher or same. That means whenever your carry flag is set means what? Carry is 1. That is your C flag. Whenever CC, the mnemonic which you can use for check for that particular carry flag is either it may be a carry set or HS, higher same. Okay, higher same or carry set. So any of these two mnemonics you can use. Okay. So third one, fourth one you are going to have is carry clear. So carry clear, as the name indicates, clear. Clear means what? Your carry flag is 0. Your carry flag is 0. Okay. So whenever you are doing the operations with respect to the negative numbers, so that is minus. Okay. So minus indicates that your negative number is 1. Okay, negative number is 1. Plus indicates that the number which you are going to have is 0. The negative in flag is set to 0. So it is overflow set. So VS, that is overflow set. Okay. So V stands for overflow set. What it is going to have? The mnemonic here. So overflow set is nothing but what? Whenever the overflow flag is set to 1. So just you have to keep in your mind when you are referring your textbooks. Okay. Wherever the capital letter is coming, it is treated as 1. Wherever the small letter is coming, it is treated as 0. Okay. So now VC means what? Overflow clear. Okay. VC stands for overflow, V overflow, and C stands for clear. So since it is overflow clear, your overflow flag, which is V flag, is set to 0. So similarly, when you are doing the operation with respect to the unsigned numbers, okay, so you're going to have the two different context. So that is one is with respect to the signed number, other is with respect to the unsigned number. So when you are referring with respect to the signed number, okay, so here unsigned higher is there. So whenever you are going to have the unsigned higher, it is going to check two flags. So what are the two flags it is going to set? You can see it here. One is zero flag is set to 0, and your carry flag is set to 1. So it has to check when you are going to operate, when these two conditions has to be satisfied with respect to the previous operation, you are going to make use of this particular mnemonic in your instruction. That is with respect to the branch. So these mnemonics you are going to use whenever you are going to make use of the branch instruction after some operation. After some operating operation, conditional instructions, if you want to do some branches, so you are going to make use of that one. So the next one is ls. Ls stands for lower. Okay, unsigned lower or same. Lower or same. Okay, unsigned lower or same. So this is going to be set when your z flag is 1, your carry flag is 0. Okay. Similarly, you are going to have greater or equal to. So greater or equal to is so on. When you are going to have it is when you are going to have your overflow flag and negative flag is high, or your overflow flag or negative flag is low. When any of these two conditions are satisfied, either both n and b should be 1, or your both and n and b flag should be 0. Okay, so when this condition is satisfying, you are going to execute this particular instruction. So now less than is going to have, so your n flag is 1. So that is the first number is negative, negative number which you are going to get. So next you are going to have the over flag as 0. So when you are going to have this particular condition, you are going to make use of less than. Similarly, if you are going with a greater than, it is going to check three flags. What are the three flags it is going to set and check? So it is going to check for negative flag. So your negative flag should be 1, and your zero flag should be 0, and your overflow flag should be 1. Or other condition is what? All your negative flag, z flag, overflow flag should be 0. Okay. So the next is less than or equal to. So when you are going to have the less than or equal to, it is going to check either 0 flag should be 0, or your n flag should be 1, and zero flag, overflow flag should be 0, or your n flag should be 0 and your overflow flag should be 1. Okay. So next is always unconditional. So it is unconditional branch. So either you can have BAL or B. So both are same. So normally BAL you are not going to use. So it is unconditional branch, because without checking any condition, it is going to make the branch. So now whenever you are going to make use of these instructions, so this particular conditional branch mnemonics, so normally you have to check for it will check for the carry flag status. It is going to check for the flag status. Okay. So depending upon the flag status, that particular jump is going to make, depending upon the previous instruction which has been executed. So now here, normally in your program, you are going to make use of HI and low S. Okay. So normally in most of the instructions, you are going to use I or low. Okay, I or low only. These are the two instructions which you are using. Or you are going to make use of CS, that is the carry set. Okay, so that is you are going to make use of this one. So carry set or carry clear. So we are going to check with respect to the carry. Okay, so then these two instructions we are going to use normally in your programs, in your class programs which you are going to have, and these two you can use. So normally used instructions are what? Normally used instruction is your EQ, NE, CS, CC, high, or low, or same. So these are the six branch mnemonics. Okay, that is conditional statement mnemonics which you are going to use regularly in your programs. So remaining, you can use it, but when you are writing your program by your own, you have to use that one. You have to write in such a way that whether I can use that, you have to think and you have to write. So whether that particular mnemonics can be used or not. Okay. So that's what your conditional mnemonics is. Just have brushed up. So all of you understood now how the mnemonics will be written depending upon what? This I have already explained in your theory class. So just have been brushed up. That's it. So other thing which you're going to have is like branch interpretation normal use, what you're going to have. Like branch BAL is there here. So you can take it here. So branch BAL. So it's always the unconditional branch. That means without checking any condition, it is going to make a jump. Okay, it is going to make a jump without any condition. Okay, so it is similar to your continue in your C program if you know that one. Okay. So like branch equal to is there. So whenever the previous there is a previous when this particular when this particular branch is going to be executed, when your zero flag is set to 1. Okay, when your zero flag is set to 1, this particular branch is going to take place. Okay. So next, branch not equal to. So this branch not equal to is executed whenever your zero flag is 0. Whenever your zero flag is resulting in 0, then your zero flag is set to 1. Okay. So normally what will happen? Assume that I have the sub as uh, assume you are going to have R5 is equal to 4 F5, and your R4 is 6 is R5 is 5. Uh, okay, R5 is 1. Okay, normally I will take this as an example. So then if I subtract R5 comma R5 comma hash 1, what will be the next value of R5? The R5 value will be 0, the next, because initially the R5 value is 1. Okay, so when you subtract this particular thing, R5 contents by 1, it will reduce to 0. Now when it reduces to 0, your zero flag which will be there, it will be set to 1. The zero flag will be set to 1. So after that one, if you make a conditional statement, the conditional execution like branch equal to. So branch equal to refers to what? It will check that whether your zero flag is set to 1. If zero flag is set to 1, then I have to make a jump. If zero flag is not set to 1, then I should not make a jump. So now normally what will happen, that depends upon you how you are going to write the program. So it is up to the programmer's point of view. So the programmer can write use branch equal to also, branch not equal to also. That you should know that how efficiently you have to make use of the code there. So that you have to think and you have to write in many fashions the same program. If you write the same program in different fashion, then you will understand how to write the program. Okay. So next, this is BPL. So BPL is branch on plus. So results plus positive or 0. So branch on minus. So branch on carry clear. Branch on lower. This one branch on lower. Branch on carry set, or branch on unsigned comparison with higher or same. So it is branch on overflow clear. Okay. Branch on overflow set. Branch on greater than. So if first element is greater than the second element when you are comparing. So if first element is greater than second element, it is going to make use of the greater than. But this instruction will be used for signed numbers. So this particular numbers when it is using, it is to be used when you are making use of the signed numbers. So when you are making use of signed numbers, you are going to make use of. So if greater than or equal to, it's going to check both for zero flag and greater or equal. So next it is less than. It's also for signed integer, as you can see that. So this is signed integer mnemonics which you're going to have this part. So that means up to here you're going to have this particular sign part. So branch less than. So this is branch less than or equal to. So if the first element, when you're comparing it, the first element is less than the second element, so then it is going to make a jump. So here it is branch on higher. So when it is going to be higher, first element is greater than the second element, then it is going to make the branch. So it is lower. Then the first element is lower than the second element. These two. It is going to be used for your unsigned number. So these two normally will be used for your unsigned number. Okay. So this is how the brief what I have been told here. Okay. So you just go through it once, then you will understand, because with the example I have explained in the class. So if you have any doubt, you can ask there. Okay. So the next and the last program in your part A. So part A last program, what it is going to tell is, so the 8th program which you are going to have. So we have to write a program, write a program to count the number of ones, to count the number of ones and zeros in two consecutive memory location. In two consecutive memory locations. So just write down the title. Okay. So this is your last program for your part A. So this is the software part. So part B is entirely your hardware part. So in your hardware part, you are going to write entirely in your C code. So you should be proficient in your C code to understand the codes. Okay. So because the codes are easy, but you should know how to efficiently use your bitwise operators there in your C program. So all of you, I suggest you do it. So you just go through how to use the bitwise operator. Okay. For your part B programs. So for your part B programs, you require bitwise operators. So now when you are going to have here, so in your this particular program, all of you have taken down the title. If you have taken down, we are going to start with that one. So now, as the name indicates, so here it is telling that we have to count the number of ones and zeros in two consecutive memory location. It is telling, because I assume that one memory location is going to have one data. For example, I am going to have 22 in hexadecimal value. So other memory locations, if I take, so let it be having 33 is the hexadecimal value which is going to have. Now, can anyone tell that what is the total size of the data you are going to take? Total size of the data which we have considered here. Oh, what is the total size of the data considered here? Can anyone tell? They are telling that it is two consecutive memory location. They are telling that it is two consecutive memory location. So now if it's a two consecutive memory location has to be considered, what will be the size of the data which you are going to have? What is the size of the data which you have to consider? Can anyone tell? Are all of you listening?
2 bytes.
Yeah. So the total size of data to be considered is 2 bytes, because in the program title they are told that two consecutive memory location. So that means I have to take the data from two memory location which are continuous. Okay. So that may be one, maybe 4 lakh or one 4,000, 40,000. I'm just for your reference, I'm taking that's it. For another is 4,001. Okay. So that is two memory location is going to consider. So the total number of bytes to be considered is 2 bytes. Okay. So now here the logic in this particular program, what they are going to use is rotation. Rotate instruction they are going to make use of. So that is your rotate right. Okay, rotate right instruction. So now in the rotate right instruction, what will be happening? So all of you know the rotate instruction, right? So all of you know the rotate instruction, I think. 1, 2, 3, 4, 5, 6, 7, 8. So if you take 0, 1, 2, 3, 4. Okay. So if you want to have 16 bit of data, you're going to consider this one, right? So now when the rotation starts, so can anyone tell what is the, so for example, I'm taking the value of 22 and 33h. So if I load it, so it will be what? 0, 0, 1, 0. That is 2. So that is a 2 I'm going to load it. So here also it is going to load with another 2. So here this particular 4 I'm going to load it 3, 0, 0, 1, 1. So then again 0, 0, 1, 1. So when the rotation takes, so how the rotation will be done? Can anyone tell how the rotation will be done? Now if you consider this one is LSB, your 0th location which you are going to have LSB, and the 15th is your MSB. Now when the rotations happen, whatever the data is there in LSB, it will be moved to MSB by 1 bit. Okay, I have to rotate by 1 bit. So rotate instructions by 1 bit. So when you are doing the rotate instruction by 1 bit, so here, so in the next instruction, what is going to happen? So here, if you take, and if you write with respect to the analogy here, so what will happen? So here 1 will be moved, 0, 0, right? So this will be coming to here, rotate right. So this particular base will be coming to 1. So similarly, whatever the 0 you have been at the LSB, it will move to LSB. That is 0, 0, 0, 1, 1, 0, 0, 1, 1, 0, 0, and again 1, 0. So next, what will happen here? If you do only a rotate operation, it is going to rotate. But if I'm using the suffix s, rotate s, what it will do? It will update the flag. It will update the flags. Which flag it is going to update? It is going to update the carry flag. Okay. So when you are using the RORS, that is rotate right with updation of the flags. S suffix tells that it is going to update the flag. Which flag it is going to update? It is going to update the flag. So how, which by which data it is going to update? The bit which is moved recently. Okay, the last bit which has been moved. Okay, so if you take the rotate right, the last bit moved. The last bit moved is copied to, the last bit moved is copied to carry flag. So that means if the last here in this particular example, I have done it for 1 bit. Which bit will be moved to carry flag? Can anyone tell? For this example which we have considered, which bit will be moved? Which bit will be moved? Which is the bit mode? Which is in LSB?
1.
No, last
LSB.
bit. LSB is which one is there? Initially it was 0, right? So I am doing that particular bit by 1 bit. So if a bit means what? Which is the bit mode? 0. 0 is taken out from this particular place. Okay. So that means the data which is moved from this particular bit, that is LSB, is copied to carry flag also. So that means here the mode bit is 0. That particular 0 is copied to here. In the next iteration, what will happen? In the next move, if I rotate again by 1. So what is the data you are going to move? So if
1.
you're, yeah, 1. Yeah, 1. Okay, again, if I'm moving the next time, what beta will be? It will be moved. So this will be coming here at that time. So again, it will be 0. Okay, so that's how it will be done. Okay, so if you want to understand clearly all 16, I will show it for only 8. So that the same thing will happen for your all 16 bits. Okay, so just to clear it, this one. Okay, so just I will show it for 8 bits. Okay, so but you have to do in the program for 16 bit. So for example sake, I am showing it for only 8 bit, but for in the regular code I have to do it for 16 bit. That's it, nothing else. So in one, so just I'm going to take them some value as assume that I'm going to take as a 77H. Okay, so that means in the data it will be having what? 0 1 1 1. So that is 7 is one side, 0 1 1 1. So it is how it will be represented. So next I'm going to rotate this for another iteration for this particular example. Okay, so when I'm making the rotate right, so if I'm going to rotate right, the contents of, assume that, now let us assume that this particular data I'm going to store it in R1 is 77H, what I'm going to store here. So I'm going to rotate right the contents of R1 by how much? By 1 bit. So if I'm rotating the contents of R1 by 1 bit, so whatever the bit is there at 0th position, so that will be moved to, MSB. That is 1 is there, that will be shift, that will be moved out. Okay, so 1 is there, it will be moved out. Remaining is 1 1 0. Again it is 1 1 1 0 1. So now simultaneously what will be copied? Carry flag. What will be copied to carry flag here?
1.
Yeah, 1. So in the next iteration, what I will do, the same operation I'm going to perform. So the same operation again, I'm going to rotate right. So rotate right R1 by 1 bit. So again, I'm going to rotate it for 2, 3, 4, 5, 6, 7. So here again, it will be 1, 0, 1, 1, 1, 0, 1, 1. So because this bit will be coming to here, this bit will be coming to here, this bit will be coming to here, this 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 will be coming to here, and the MSB which is there, that will be shifting to last one. So again, your carry flag will be loaded with what?
1.
Yeah, 1 again. So next again, in the fourth iteration, for example, I'm telling. So in the fourth iteration, if I'm doing, so in this one, after doing the rotate operation here again, rotate right the contents of R1 by 1. So what you are going to get in this particular provision? Last bit in the LSB, it is 0. So again, it is 1, 1, 1 you are going to get. Again, it is 0 here. Again, you are going to get as 1. Simultaneously, your carry flag will be set to 1. Okay. So next in the fifth position, again, fifth iteration I'm going to do. So again, I'm going to move it. So now, so here it will be 1, 1, 1, 0, 1, 1, 1, 0. So after doing the rotate right instruction, here what is the value of the carry flag which is moved, which is the bit which is moved here in this particular rotate instruction, which is the data which is moved there. It is 0. Yeah. Now this one I will do for 8 rotations. Assume that this particular rotation I'm going to do it for 8 rotation. So I'm going to do for rotate right for 8 times. Now after doing the 8 times, can I find that how many bits of 1 is there if I'm doing that one by checking the carry flag? So here I am doing for 4 rotations, right? Now I have done for 4 rotations. Another 4 rotations I'm going to do it. 4 times I have done for your example here. So now how many times the carry flag is set?
7.
3 times.
Now here in this considered example, it is 3 times, right? Next again, how many time it is not set?
1.
Yeah. Now if I'm same thing, if I'm going to do it for 8 times rotation. So how many times your carry flag will be set?
3 times.
If I do the rotation for 8 times, I'm telling again it is 3 times, right? Another 4 rotations I have to do. If I'm doing that again, I'm doing 3 times, it is carry flag will be 1. So carry flag is 1. So now if I combine those two, how many times the carry flag is set?
6.
Yeah. How many times the carry flag is 0?
2.
2. Right? You understood, right? Now you can see it here. So once you are done, so the carry flag is set for 6 times here. So okay, the carry flag is set for 6 times. So since it is carry flag is set for 6 times, you can consider the first number here 77. Okay, so here you can consider it here. So how many in this particular number, how many bits are 1?
3.
No, total I am telling. Total 8
6.
out of 8 bit. Yeah. Total 1 bit is what? 6 is there. So 0 is how much is there?
2.
Yeah, 2 is there, right? So that is 1 bit I'm going to have 6. 0 bit I'm going to have 2. So now when I'm doing the operation, you can check that for both. You are getting the answer. If I go with the checking of the carry flag, can I get the answer for that one? If I use the logic of this one in the program, in this particular program, we are going to use this particular logic. Okay. Any doubt? Anybody having any doubt? Anybody having any doubt?
No, sir.
Okay. So this is what we are going to write it in the code. Okay. So we are going to get the number. So now according to the title of the program, how many, for how much data I have to find the number of ones and zeros according to the title of the program?
2 bytes.
2 bytes means how many bits it will be there? 2 bytes, how many bits?
16 bits.
Huh?
16 bits.
Yeah, 16 bits, right? So now, if I'm going to have to find the number of ones and zeros for 16 bit, how many rotations I have to make?
16.
Yeah, I have to make the 16 rotations to find the number of ones and zeros. Okay, you understood, right? So this is how the logic works now here in your code. Okay, 1 minute. I will erase everything. So now, so initially what I will do, I will go with area. Normal area I am going to get. So it is name of the program I am going to write. It is program 8. So the type of the memory which you are going to use is code, and that particular memory is only read-only memory, what you are going to have. So I am going to have the entry point. So I am going to have the entry. So this particular code is a case, not a case sensitive. You can use either big letter also or a small letter also, combination also it will work. So that doesn't matter there. Okay, next you are going to have the start. Okay, start. So now first I need to have the memory. So where my data is kept, that is 2 byte of data is kept in some place. So that I am going to refer it as memory here. So that is memory. I'm going to define that one as BCD. So that is starting address of data where it has been stored. That I am going to store in the memory location memory by variable. So this particular variable, this is memory is nothing but the variable here. Okay, this particular memory is nothing but variable. So all, as I know you that, as you all you know understood that variable is nothing but what? Named memory location that you have to keep in your mind. So it is named memory location. Some name they have given for some memory location, because I don't know the memory location. What is the memory location? This memory is residing, but I'm giving the name for that one. What is that particular memory is of type? I'm going to define that particular memory is of type as DCD. So DCD stands for what? DCD stands for what? DCD stands for what? You should know all these things. If not, it will become difficult for you. So define constant double word. So define constant double word. So if it is double word means how many size of, what is the size of that particular memory? How much data it can store, that particular memory can, how much, what is the size of the data that particular memory can store? Double word. So word is how much, how many bytes? One word is equal to how many bytes?
1 byte.
Word. One word. One word is 2 bytes. You should go through the basics, right? One word is 2 bytes.
DCD is 4 bytes.
DCD is 32 bits.
Yeah,
4
I am
bytes.
telling one word I am asking. One word is yes, how many bits? How many byte? 2 byte, right?
2 bytes.
In your DCD, it is going to tell that define constant double word. Double word means what? 2 words. That you have to understand. 2 word means 4 byte. Okay, 2 words means 4 byte. So I can store up to 4 bytes of data in this particular memory location. So what is the data I am storing? I am storing it in that particular memory location 0x40000. This is the data which I am storing it there. This is nothing but what? This is nothing but the address where I am going to store the data. This is nothing but the address where I am going to store the data. So that I am going to initialize here in the memory at the end. Okay, this memory variable declaration has to be done at the end in your program. So that I have done here. So next, I need to get the data. From where I need to get the data from? First, I need to get the data from the address 0x4 lakh. So for that one, I need to load data from the memory. So LDR or not, comma, memory. So memory is located in some address. So that means if you take the memory, so memory is having some address, random address, it will be generated by your compiler, heel compiler. So it may be some 01 or 0x or some like some address it will be there. So here how it will be stored 00 00 00 40. Why it will be like this? Can anyone tell?
4 bytes of data it is.
Yeah, 4 byte. So the lower byte will be stored in the lower address because it is a little endian. Since it is a little endian, how the data will be stored? Lower address, lower byte. Okay, here the lower byte is 00. The next lower byte is another 00. The next lower byte will be another 00. Okay, another 0 here. So next lower byte will be 40. So like this it will be stored. So that will be loaded into the R0 now. So this is your 3 lakh 2, 3 lakh 3 is the address of what? This is the address of memory. In this particular address, what data is stored? Another address I have stored. So in your C concept, what it is called as? Can anyone tell? Address of address. Anybody knows that one? Have you heard or not in your C programming? What is a pointer in your C? What is a pointer in your C program? What is a pointer? Can anyone tell what is a pointer? Pointer is a variable which holds an address. Here I am telling address of a address it is going to hold. So now it will become double pointer. Have you heard of double pointer? So double pointer is there. So how many you can have n number of pointers that you should know when you are working with respect to embedded system, especially when you are referring with respect to the embedded system, you should know all these pointer address of address of address of. Okay, so that means what? Your ampersand represents address. Okay, so when I am referring it, so this is a pointer which will hold the address. Okay, so that is pointer is a variable which will hold the address of the another variable. That is the normal definition of your pointer. So now, so this you require in your part B part of the program. That when I come, I will explain that one. So before that one, you just go through the basics of your pointer first, because if you don't know the pointers concept there, it will become difficult for you to represent it. Okay, just go through it once. So next, when you are going to have LDR R0, memory, so the data which is stored in the memory, which is 4 lakh, it will be loaded into R0. So now I am going to store the data in R0. So now I have to fetch the data from R0. How much data I have to fetch it from R0? According to the program title, how much data I have to fetch? According to the title, I have to fetch 2 bytes of data. So to fetch the 2 bytes of data, I will use LDRH. LDRH, comma, R1, comma, contents of R0. Okay. So now the data which is stored in 0x 4 lakh, it will be loaded into, just I will make the word here. Okay, make a space first.
So if you are in lobbies, they're trying to join.
1 minute. But it's not visible for me here.
Okay, sir.
So here, so what it now? So it is LDR R0, memory, and I'm going to load. So I am assume that in 4 lakh address, I'm going to store some number. like 77, 77 I'm going to store. So in your R1, what it will be stored after that one? Your R1 will be having, so 77, 77. That is the hexadecimal number which will be stored into the R1. So remaining 16 bit will be 0 itself. Next, how many rotations I have to make in this particular program to find the number of ones and zeros? How many rotations I have to make? How many rotations I have to make in this particular program?
16.
16. So I am moving the number of rotations which I have to make into one register. I am moving the number of rotations which I have to make into one register. So this will provide you the number of rotations, what I am going to make it. Okay, this is going to provide you the number of rotations. So next, your rotation starts now. Next, I will start making the rotation. So rotate right of S. Which content I have to rotate? Which register content I have to rotate?
Or not.
R0 contains the address here. From the address, I have fetched the data to which register?
R1.
Yeah, R1. So I have to rotate the contents of R1. By how many bits I have to rotate?
16.
No, because I have to do 16 rotations. 1 bit I have to rotate because I have to check each bit, right? To check each bit, I have to make a rotation of 1 bit. I have to make a rotation of 1 bit. So now you have made the rotation of 1 bit. Now I have to check for a condition. So now which flag I have to check? To check that whether that particular bit is 1 or not. According to the logic, what I told, which bit, which flag I have to check?
Carry.
Yeah, carry flag. So I will check for carry flag. Branch on carry set. If my carry set, which register, what it suggests? If my carry is set, what that particular bit is? Whether it's 1 or 0. No. If a carry is set, whether that particular bit is moved is 1 or 0.
1.
Yeah. Branch on carry set, it is to ones. That I have to go to that one register I am going to make use of, where I will increment the contents of 1 in one of the register. So that particular flow will come to ones here. Branch on carry on flag to ones here. Okay, branch on carry set to ones. Now, one register I am going to be one variable. For example, in your C program, I am going to make use of variable to increment to count the number of bits. Here I don't have the variable. I'm going to make use of the register here. So what I will do, I will add initially the contents of R2 will be 0. All registers will be set to 0 when you are coding. I will add the contents of R2 by 1. So now what is R2? R2 is holding what? Number of 1 bit. Count. R2 is holding the count which will be having how many number of ones are there in the given data. So now if this particular carry is not set, assume that this particular carry is not set, the carry flag is 0. So this particular condition fails. This condition fails now. So if it is failing, what I need to increment? Whether I need to increment the 1 bits or 0 bits. If that particular condition fails, BCS is not 1. That is, the carry bit, the bit which is rotated is 0. That means the bit which is rotated is 0. Then I have to keep track of that particular bit also. So for that one, I'm going to make use of another register. So other register which I'm going to use is add R3, R3, 1. So if that condition fails, the next instruction will be executed. If this condition succeeds, it will jump to here. It will jump to where? It will jump to 1. Branch on carry set to 1. So the flow will come from here to here. This particular instruction to this particular instruction, it will come. If this particular condition is satisfied, if your carry flag is 1, so it will not execute this particular instruction at that time. In between these instructions, whatever you are going to write, those instructions will not be executed. So it will come directly from branch carry set of ones. From here to here it will come. And it will execute what instruction? Add R2, R2, R1. So if the moved bit is 0, then this condition fails. That is, your carry flag is 0. This branch on carry set is failing. If it is failing means what? It will execute here, this particular instruction, this next instruction. Next instruction, what is there? It will hold the count of number of zeros. It will hold the count of number of zeros. Okay. So that is keep track by R3. That will be keep track by R3. So now, next, once this is done, where I need to jump? What I need to do next? I have to branch to next. Okay, so branch is an unconditional execution. It will just simply go to next without checking any condition. So the next will come here. So now what is the operation I have to do now? Can anyone tell? I need to decrement the rotations. Number of rotations has to be decremented. Now initially I have to do for rotations as 16. Now the number of rotations has to be decremented by 1. So that means who is keeping track of the rotation? Which register is keeping track of the rotation?
R4.
Yeah, I have to subtract your R4. By how many bits I have to subtract? How many times I have to subtract? 1 time. So I have to subtract it by 1 time. So now I have to check for which condition. Whether now initially what was the count for R4? R4 is 16. Now it is coming for R4 is equal to how much? 15. So whether it is equal to 0 or not, I have to check. So if your 0 flag is 0, then I have to make a jump, right? So branch not equal to I am using. Branch not equal to. So that means your 0 flag is still 0 itself. Where I have to jump again, I have to rotate. Okay, so 1 minute. I have to rotate. So this particular rotation I will be starting from here. Rotate. Anybody having any doubt? Anybody having any doubt?
No, sir.
Okay, so this is the code. Now, once all these 16 rotations are completed, which register is holding the count of number of 1 bit? So it is going to do it for how many bits? It is going to make the rotation of 16 times. 16 times the rotation will be doing. So 16 times once the rotation is done, that is it is going to, so in the next time what will happen? It will check whether it's 1 or not. So if it is 1, so what will be happening? So if it is a carry is set, so then it will come to the control flow will come from here to here. It will add the contents of R2. It will increment the contents of R2 by 1. So if the moved bit is 0, it will increment the contents of R3. Okay, that means your R2 is holding the count of ones and your R3 is holding the count of number of zeros. Okay, so your R2 is holding the count of number of ones and your R3 is holding the count of number of zeros. Okay, any doubt? Anybody having any doubt?
No.
Okay, so next, once it is done, what after getting the number of ones and number of zero, I have to store it to some address. I have to store that particular values to some address. So now already I know that some the starting address where I am keeping the data is this one. Okay, 4 lakh is the address. So I will use two memory locations I have used for that particular purpose. Two memory locations I have used for that particular memory location. So I will store that data in 0x40004. That is number of ones I am going to store it here, and your number of zeros I am going to store it in 4005. So this particular numbers. So if I take the 77 is the example. If I take, so your 44 is having in 6, and your 5 will be having here is 2. Okay, so that I have to move. So I have to fetch this particular address. Presently, your address is where now? So presently your address is how much? What is the address which is there in R0? Your R0 contains 4000. Now 4 lakh. Okay, so 4 lakh is the address your R0 is having. So now I have to make that one address as 4004. So to make that 4004, what I need to do? I need to add. Okay, I need to add the contents of R0 by how much? By 4. My contents of R0 to 4, I'm going to add it. 1 minute. So just I will erase this particular part. It should not get confused for you people. Okay. So now, what is your R0 is pointing to now? Your R0 is pointing to now 4,04,000 is the address. To this particular address, I'm going to move the data of R2. So R2 is holding what? Count of ones. Count of ones it is holding, right? So I have to move the data from register to memory location. To move the data from memory register to memory location, what is the instruction I have to use? To move the data from memory location, register to the memory location, what is the instruction I have to use?
Store.
Yeah, store. How many bytes of data I have to store? Here, only 1 byte. So that means I should have strb. I'm going to store 1 byte of data. So strb, from which register I have to store? From which register I have to store? I have to store from R2 to where? To the memory location specified by R0. So in this particular data, it is going to store 6 now. After the execution, if I'm taking the example as 77, okay, 77 or 77, some numbers we will take. So assume that you are going to take 8, 8 and 7, 7 for example. So 6 plus 2, 10. So instead of A will be there. Okay, so A will be there. So next again, I need to store what? Then a count of number of zeros. I need another address for that one. So I need another address. So I will store that particular count. Now count of it is count of ones. Here I am going to store. So here I am going to store the count of zeros. So here I am going to specify that one as 4005. In the 4005 address, I am going to load that one. So now presently your address is pointing to 4004. That is R0. So again, I will add the contents of R0 by 1. I will add the contents of R0 by 1. So when you add the contents of R0 by 1, the new R0 will become 4005. So that is nothing but the address to where I need to store the count of number of zeros. I need to store the count of number of zeros. So next again, once I fetch that particular address, I need to store. So store bytes from where? From R3, because R3 is holding the count of number of zeros. Count of number of zeros to where? To R0. To R0. So next it is going to halt the program after this one. Just it's a you are going to make is unconditional branch statement. So that particular code will be stopped here itself. Okay. So this is the logic how we are going to do. So anybody having any doubt? Anybody having any doubt? If anybody having any doubt, you can ask now. Sorry, if you are hesitating to ask, you can put it in a chat box if you have any doubt. If you have a doubt in any, if you have any doubt, you can put it in a chat box also. Whatever the doubts you are going to have. So anybody having any doubt, you can post it in your chat box. If you are hesitating in asking, anybody having any doubt? Anybody having any doubt?
No.
Okay. Only one person will be replying. What about the rest? Around 40 students are there in the class in this particular meeting. 1 or 2 will reply. That's it. What about the rest? So now, so just we will execute this particular program. Okay, we will execute this particular program now. So just I have created that one already. So we'll just type the program. So this is the area. So I'm just giving the name of the program as program 8 or count 1. So some number name I'm going to give. So that is your wish. Whatever may be the name of the program you want to give, you can give. So that particular memory is of type code memory. So that is code memory you are going to use, and that particular memory is only read only. So that is only read only memory. So I have to have the entry point for that particular code. Once you have the entry point, I have to start the code. So start the code. So first you need to load the data from the memory. So load the data from the memory. That is nothing but I'm going to load the address. So I'm going to load the address where the data is kept. So load the address. This one, the load the address of the memory, load the address of the data to fetch. So next I need to have I need to fetch the data from that particular address. For that one, LDRH. Okay. So LDRH from where to where? From R0 to R1. So I'm going to get the data from the memory. So that is the address where it is being stored. So I'm going to define it at the end, the variable definition. So next you are going to move. So I'm going to have the counter. So here the counter, what you are going to have is 16, number 16. Okay, so number 16 you are going to have. So this is count. Okay, so this number of rotations which you are going to make. So it is number of rotations you are going to make. So it is nothing but the number of rotations. So next, once it is done, I have to rotate it. Okay, rotate right with updation of the flag. Which content I have to rotate? I have to rotate the contents of R1. That is where the data is stored. By how many times I have to rotate it? By 1 times. By 1 time I have to rotate it because I have to check for each bit. So rotate right with updation of the flags. So then if branch if carry is set, count the number of ones. Okay, so it counts the number of ones. I'm going to come to ones now. So the flow will come here and it is going to add in one register. I'm going to take this particular register to count to number of ones. Okay, so I will add one number if the one is encountered there. So now again, I need to subtract it. I need to subtract the counter. So counter is stored. Counter will be kept track by R4. So I'm going to decrement the contents of the register of R4 by 1. So next, if the contents of R4 is not 0, if the contents of R4 is not 0, where I have to do? I have to make another rotation again. I have to go for rotation. I have to rotate again. So go for rotate. So this particular label will be coming here, rotate. So this particular control will come to there, this particular label. So where rotate is a branch are not equal to rotate. So this particular rotate to where it has to jump, it will jump to here, rotate. Okay. So now, if the branch on carry set is not done, so if the mode bit is 0, then I have to keep track of count of number of zeros. So that I am going to keep track using R3. Okay, that I am going to keep track of R3. So it is R3 comma R3 comma 1 dash 1. Okay, so that we are going to have. So this is. So next, I need to branch to next. This unconditional branch. So after that one, I have to go to and do again decrement the counter. So if it is not satisfied, okay. So once it is done, I have to, once all the rotations are completed, so your program, you are going to have the total count of number of ones in the given data is stored in R2, and the count of number of zeros in the given data is stored in R3. So the contents of R2 and R3, I have to move to some specified memory location. So I am going to move to the memory location which I have been already using it. Okay, so this is just one mistake is there or not? Okay. So next I'm going to add what the contents of R0 by 4. So initially it will be, I will increase the address by 4 bits. So initially it will be 4,000, 4 lakh, 40 lakh. So next it will go to 40 lakh 4. So to that particular place, I have to move the count of number 1. So the number of 1 is stored in R2. That I am going to move it to R0. Okay. So next I'm going to add increment the address. So increment the address R0 with 1 byte. Again, I'm going to store the contents of R3, which will be holding the count of number of zeros to R0. Okay. So next, I'm going to have the infinite loop, which is going to have halt, B, halt. So I'm going to define one memory variable. Memory, it is of type DCD, that is defined constant word, where I'm going to store the address. Okay. So I'm going to store the address. Then it is end. So that will be end of the program. Anybody having any doubt? You can ask. If you have any doubt, if any clarity is required. So if you have any clarity to be done for this one, you can ask. Anybody having any doubt? Anybody having any doubt? Let's go through it once. Just save it, run it. So build the target first. So after building it, you will get 0 errors and 0 warnings. So go to debug, start or stop debug session. So once you start or debug session, you are going to get this one. So now it is going to load the data which is stored in memory. The data stored in memory is 40 lakhs. So that will be moved. Okay, so that will be moved here. So next 4 lakh, you can see it here. So your R0 contains 40 lakh. So that I have to store the data now in 40 lakh. How much data I have to store? I have to store to 16 consecutive memory location. That is 677 and 88 I'm going to store. So that is consecutive memory location I'm going to store. 2 bytes of data I have stored that. Since one memory location is going to one memory location can store 1 byte of data, 2 memory location can store 2 bytes of data. So next, from that particular address, I have to fetch the data, which is stored in 40 lakhs. Okay, so here you can see it here. So now, from that particular address, I have to move the data. How much data I have to move? I have to move 16-bit data. That's what I am going to make use of LDRH. Okay, LDRH. So it has to move the contents of R0 to R1. So when you execute this particular instruction, your 8877, it will be moved to R1. So you can see it here. All of you can observe, right? Your 8877, which is moved to R1. So in the registers window, you can see it here. So that is 8877. All of you can see that one, right? All of you can see, students?
Yes, sir.
Okay. So next, once it is done, I am moving the number of rotations to be done in R4. So when I click next, the number of rotations, R4 is having 10. So 16 is in hexadecimal. If you convert it, it will be 10. Okay. So 16 number, decimal number, if you convert to hexadecimal number, it will be 10. So the hexadecimal value of 16 is loaded in R4, which is 10. Okay. So next, I will start rotating the bits by 1 bit. So rotate right the contents of R1 by 1. So I'm going to rotate it. And after rotating it, I have to check for my carry flag. So you can see it here at the problem. Your carry flag is set to 1. All of you can observe that one. Now your carry flag, you can see at the bottom, your carry flag is set to 1. All of you can visible, right? Can see that one. You can see, right?
Yes, sir.
Okay. So now, depending upon the carry set. So if the carry is set, where the control has to go, it has to go from ones to ones here. Okay. So the control has to jump to this particular ones label. So the control will go from this particular address to this particular address. Okay. So branch can carry set to once. You can see it here, yellow line, which is there at the right. Okay. So that you just take it out in the code part. Okay. So that's next. When I press next execution, it will go to next. Okay. Branch next. So it is going to add one. So it is going to once is so so branch once it will come here. The flow comes here. It will add the contents of R2. Okay. So presently the contents of R2 is 0. So it has to increment the contents of R2 by 1. So now it will be 1. So R2 is 1. You can see that one. So you can see it. So R2 is 1. So next, again, I have to rotate it. I have to decrement the counter number rotation. So it will be, initially it will be 16. Now it will become 16, 15. So the presentation of 15 hexadecimal is F. So that you can see it in R4. That is, had been reduced to F. So again, it has to go to the rotate right. So again, it has to go for rotate right. Branch on next. Next, it will rotate. If since your R contents of R4 is not equal to 0, so it will go to rotate. Again, rotate it will do. So it will check for the carry flag. So if the carry flag is set again, so it will the increment by R2. So now you can see it here. R2 is 2 because the content being rotated is 1 only. So because the data what we have taken is 8877. Okay, 8877 is the data what we have taken. So the first 3 bit which will be moved is 111 only. So that's why I am not showing the carry flag bit. So in the next rotation also it will be 3. So next rotation it is going to add the contents of 3. Okay. So next after that particular rotation, okay, branch on rotate here. So you can see once the rotation is done. So the rotation is done now. So the rotation is done. So what is the carry flag here? You can see it here. It is in the 4th rotation. You can see in the carry flag, the carry flag is 0. Okay, the carry flag is 0. So since the carry flag is 0, this particular condition fails. That is branch on carry set is failing. Okay, you can see it here. Branch on carry set is failed in your program part. In your program part, you see that I have highlighted that part. Branch on BCS once fail. So if it is failing, it will not go to once here. Instead of going to once, what it will do, it will go to the next instruction which has to be executed. The next instruction which has to be executed is add R3, R3, #1, which will keep track of the number of counts of zeros. Okay, it will go to, you can see it here now. It is incrementing. It will come here and it will add the contents of R3 by 1. So in the register window, you can see it here. Initially now, the value of R3 is 0. The value of R3 in the register window, you can see it now. The contents of R3 is 0. So next, when you execute that particular instruction, it will become 1. It will become 1. Okay. So next, branch on next. This is unconditional branch. Since it is branch, next again I have to go for the number of rotation to check. So it will come to branch on next here. Okay. So again, it will decrement the contents of R4, which will keep track of the counter. So R4 it is going to decrement. Again, it will start. So again, so how many times the same process will be repeated? It will be repeated for 16 times. Okay, that will be repeated for 16 times. So I will just repeat it. Once your R4 becomes 0, till R4 becomes 0, I have to repeat it. Till R4 becomes 0. So till R4 becomes 0, you can see from the register window. So till R4 becomes 0. So till R4 becomes 0. So now you can see it here. Now initially R4 is 0 now. Your R4 becomes 0. You can see it now. Your R4 becomes 0. When R4 becomes 0, you can see it here. The branch 0 flag is set to 1. The 0 flag is set to 1. So when 0 flag is set to 1, so even this conditional fails. So branch on not equal to rotate. So if zero flag is 0, then it has to go for rotate and it has to rotate it. So if it is equaling to 1, what it has to do? It has to terminate the loop. Okay, it has to terminate the loop. So it will come out. So after coming out, you can see in your registers because all the number of ones and zeros are counted. So the number of ones is stored in R2, which is 8. The number of counts of R3 is 8. So you take the data 7788. Can you count? How many ones are there? How many zeros are there? How many ones and how many zeros you are going to get? Manually, if you take it. Manually, if you check it, how many number of ones and how many number of zeros are there in your number 7788 hexadecimal number. So it will be 88 itself. So now that I have to store it in the address where in the memory location 4004. Okay, 4004 I'm going to store that one. So at the bottom you can see 7788 is there. This 77 is in 4 lakh 1. 88 is in 4 lakh 2. Okay, so next 4 lakh 3 is 00. 4 lakh 4 is 00. That is in memory window 3, you see to it at the bottom. All of you are seeing that one? All of you able to see that particular part? Can you able to see? Can you able to see that one? Bottom one. All of you are listening. Are able to hear? Kirtana?
Yes, sir.
Okay. So at the bottom, you can see it here. It is 00 is there. In this particular memory location, I have to put the count of number of ones. So I will go to that particular address. So now initially the address is 4 lakh, which is pointing to the starting location. Now I will increment that particular address to 4 lakh 4. Next in the store byte. So I am moving the data 8. So once this particular instruction is executed, you can see into the 4 lakh 4 that the data which is stored in R2. So the data which is stored in R2 is 8, which is nothing but the count of number of ones in the given number. That will be stored in that particular location. That will be stored in that particular location. So you can see it here, 8 is there. So you can see now 8 is specified in that particular location. Next, I have to display what? I have to check for number of zeros. So to check for number of zeros, I have to use another location. For that one, I am going to increment the contents of R0 by another number that it will now point into 5, the next number. So there I am going to load the data which is stored in R3. So here, as we know that the R3 contains what? The R3 contains the data. R3 contains the count of number of zeros. So that I am going to move. You can see it here. It is 8 and 8, which you are going to get it. Okay, 8 and 8, it will be there. So then it is going to halt the program. So that is how the program code works. So if anybody having any doubt, you can ask now. So if anybody having any doubt, anybody having any doubt? Anybody having any doubt, you can ask.
No.
Okay. So just take this, note this particular program. Can you able to see the program? Just note it down. Note the program. So in the same way, you have to type it in your lab also. In the same way, same fashion only, it has to be properly indented. So indentation should be proper when you are executing the program. So I will take another data and I will give another example. That's it. So just you can see it here. So it is done. So it is going to load it. So I'm going to store some data. I'm going to store some, let us say 8888 only. 8899, let us take some number. So what if I take 8899, how many number of ones should be there? How many number of zeros should be there? Can anyone tell? If I take the value 8899, how many number of ones and how many number of zeros should be there? How many number of ones? How many number of zeros will be there?
Four ones, sir.
In 8899. 4 ones. Just take it out. If you know it in hexadecimal number value, convert 8 into hexadecimal value, which will be 1000, 1000, 1001, 1001. How many ones are there?
Four.
It is represented in hexadecimal value, Kirtana. You just check it out.
Oh, yes, sir, yes, sir. Got it. 1 minute.
Don't get confused. If you write directly, you write it in hexadecimal value only. So that is 8899H. So it is nothing but what? 100, 1000, 1001, 1001. So that is, it is having two ones. This is having two ones. This particular part is having one. This particular part is having one. So the number of ones is 6. So similarly, the number of zeros will be 10. So it will be stated as A. This will be treated as in 6 only for that particular part of the code. Okay. So it is done. So after executing, so just execute it. So once it is completed, once your R4 becomes 0, number of rotations. So you can see it at the bottom. So the number of ones is stored in 4004, which is 6. So at the bottom of the screen, and the number of zeros is 10. So if you represent 10 in terms of hexadecimal value, it will be A. If you represent 10 in hexadecimal value, it will be A. Okay. Anybody having any doubt with respect to this particular program? Anybody having any doubt? So one more thing which you have to keep in your mind is, so just in the last class we have discussed only about the ascending order. Okay. So if I want to go with the descending order, what I need to do? Instead of BLS, you have to use BHI. Okay. So just make a note of that one, the previous code, what have been done. So that you take it as assignment and you send it. But for your two programs, you have to do it by yourself. That both I have explained, that is largest or smallest. That is your sixth program, I think. So that we have done it for largest. You have to do it for smallest. Only one part you have to change. That is what, where it is a branch. Branch instruction is only one part you have to change it. So that you should know which instruction you have to use when you want to find the largest one, which conditional branch you have to use, and which conditional branch you have to use when you want to have smallest one. So if you know that one, that's enough for you. So just that completes your part A. So just you make a practice of doing the code. Okay. So next. So make a practice. So just make a note that how to write your if condition, if into else, like that and all. Okay. So just if it is like this one. So just I will put one hint like logic I am going to do. So say that if I is greater than 0, so some action I am going to do. So if I is greater than 0, so just do I plus plus. Otherwise, J++. So just like this, if you take, so I have to compare with I with 0, right? So I have to compare this, if I is greater than 0 or not, I want to check. So initially check that. So initially you take some value and write it. So wherever if is coming, that you have to make use of compare instruction. Okay, compare instruction with what and what? We have whatever the value, wherever the value you are going to take, you compare with that one with 0. So compare with whether it's greater than or 0. So if R1 is greater than some number, then you make a jump. So then you are branch on equal. So if it is greater, branch on high. So branch on high is your true part. This is your true part. So it is going to have some true one, you write it, and that particular part you jump to that one and you execute whatever the instructions you want to do there. So move R2 R3 or some add instruction. What if not, what you have to do? So after that one is execute this instruction only, for example. So you are going to have this one. So you do some other instruction. If it is not true, that is your else part will come here. This is your else part. So if it is true, this is your true part. This is true is one and only instruction. False part you are going to have two instructions. False part you are going to have two instructions. This and a branch next. So else part will be having two instructions, whereas your true part will be having only one instruction. That you have to keep in your mind when you are executing with respect to C program to assembly code. So you like that, you do it with a different instruction. Then you understand how to write the code. Okay. So it will help you on that fashion. So if anybody having any doubt, you can ask now. So if any doubt is there, so just take an assignment like